Thanks to our title sponsor, Juniper Networks, for helping make Research Saturday possible. Hello, everyone, and welcome to the CyberWire's Research Saturday. I'm Dave Bittner, and this is our weekly conversation with researchers and analysts tracking down threats and vulnerabilities, solving some of the hard problems of protecting ourselves in a rapidly evolving cyberspace. Thanks for joining us.
And the question was, well, how many of these outdated dependencies, which might be vulnerable to some serious CVEs, are out there?
That's Tomislav Peričin from Reversing Labs, where he's chief software architect and co-founder. The research we're discussing today is titled Third-Party Code Comes with Some Baggage. Juniper Connected Security helps organizations build threat-aware networks that extend security to every point of connection across the network. To learn more, visit juniper.net/security or connect with Juniper on Twitter or Facebook. That's juniper.net/security. And now, a message from our sponsor, Tanium. In a distributed cloud-based world, managing and protecting endpoints has never been more important. The Tanium endpoint platform provides real-time visibility, comprehensive control, and rapid response for endpoints across distributed operations. That's why the Department of Defense and half of the Fortune 100 trust Tanium to secure and manage their IT operations. Want to try for yourself? Visit tanium.com/cyberwire to get a 14-day free trial of Tanium as a service. That's tanium.com/cyberwire. And we thank Tanium for sponsoring our show. Well, so walk us through how you approach this. How did you all get started on this research journey?
Yeah, so we actually scan all these package repositories continuously. One of our core missions is to be able to find any malicious packages which might reside in them. So what we do is we scan things like NuGet and NPM and PyPy and all the other open source repositories. So that drew us to the conclusion of, well, we're checking for malware. What would happen if we start looking for vulnerabilities as well?
And how did you go about doing that? I mean, what's the process for digging in here and finding what's buried in these packages?
So the package managers themselves host all of the versions of the packages themselves. You can relatively easily go and crawl all of the packages themselves. You end up collecting a vast amount of data. So NPM, I think, is about 9 million different package versions that you kind of crawl and maintain over time. And then obviously after you have all these packages, you start doing static analysis. So unpacking them, analyzing the contents, looking at, are they only using script languages intended by the package manager, or are they also including like native binaries as well?
And what did you find here? Take us through some of the results.
Well, the interesting bit is that you kind of expect that the package managers kind of serve the programmers for that platform, and you kind of expect them to have only the kind of like JavaScript in NPM world. What we actually uncovered during our research is that all of these package managers, alongside their core missions, have additional libraries and executables for all sorts of platforms. So we found Windows executables for even mobile applications on all these packages. So with that idea, then we said, okay, so we know a lot about analyzing, for example, Windows binaries, and we know, we can have static linked libraries in those applications. Is this something the developers are actually actively updating as well? So that led us through this path of, making some signatures to identify commonly used compression, encryption, and networking libraries that we know for a fact are updated all the time, and they're updated all the time because frequently vulnerabilities get discovered in them. So with those sets of signatures and doing this large data analysis, we were able to uncover, hundreds of thousands of different packages across many different versions they have that actually do still have vulnerabilities which might get exploited.
So help me understand here. I mean, is this a matter of people using other snippets of code, open source things, as you said, popular libraries and so on? Is it a matter of them using ones that are out of date and not going through the process of updating them? Is it neglect, or what exactly leads to these being consistently within the things that you're looking at here?
Yeah, so it's not on the end user. So the end user uses the package manager correctly. So they say, okay, update all the packages, bring down the latest versions. And the developers of those packages tend to update that code frequently. However, the statically linked libraries do not appear in the list of dependencies. And you have no idea if the original developer has actually updated the statically linked libraries or not. And as our research shows, there's quite a few developers out there who kind of include a third-party project and forget, and then just ends up accumulating this large number of vulnerabilities in open source repositories.
Can you give us an example of some of the things that you found here?
Yeah, so we've looked for, as I said, common compression encryption libraries. And for example, zlib is the most common compression library out there. There's only like 2,000 or so versions that it has, but almost every single version has a vulnerability or two. And it's relatively easy to identify if you create a signature which just includes the banner which says, I am zlib and specific version. You'd be able to identify if the library is actually statically linking an outdated zlib version. So we did that. And through the scan, we found quite a few popularly used packages which statically link these things. I think one of the most interesting one was the application which is used to kind of edit and create new DICOM images. And DICOM images are used in medical devices, right? So this is very interesting because they're using an outdated version, and then if you're parsing an image which has a vulnerability within, the parsing itself could trigger code execution. So that's why having these libraries continuously updated is important, even though they might not be declared by people creating the packages.
So how would someone go about doing what you've done here? I mean, in order to, I guess is it a matter of how deep do you dig? I mean, if I'm developing something here and I've got these dependencies, what's the best way for me to go about making sure that there aren't these sorts of things lurking within?
So for developers, it is relatively hard because the tools they have at their disposal coming from the package managers themselves, they only show the declared dependencies. To be able to find the ones which are not, you need to use additional tools. And there are commercially available tools today called, SCA tools or software composition analysis tools. A lot of them will just, look at the package manifest as well and stop there. The ones which are really good will try to do static analysis and figure out, is there any statically linked code? Those are limited, and they tend to use a predefined set of signatures to find common vulnerabilities. So we would recommend using those in addition to open source tools.
In terms of the bad guys being able to exploit this, I mean, if it's not obvious to the developers, is it also not obvious to the bad guys that these vulnerabilities would be here, or is there a disproportionality here where the bad guys have the advantage?
It is relatively simple to create these signatures. So let's say you're a bad guy and you're trying to do kind of mass exploitation of these vulnerabilities. For the statically linked libraries, which are easy to identify, like we did, writing a simple signature will do, you can easily find the vulnerable packages, and you can find them way before the actual developers do. We haven't yet really seen large-scale exploitation like that, but given what's happening with software supply chain and attackers finding new and novel ways to exploit the developers, this might be just a matter of time.
And what about the notion of a software bill of materials? I mean, is that the sort of thing that would help out here, where if you had a manifest of everything included, would that help us get where we want to be?
Absolutely. That is the way forward. However, most software bill of materials for open source packages are being created based on the self-declared list of dependencies. Additional tooling is actually required to be able to detect statically linked code and add that to the software bill of materials. Typically, software bill of materials is created manually by the developers, and it suffers the same drawbacks as anything else, maintained by humans. It can be outdated. It might not even be accurate. It can change over time. Dependencies could be forgotten or added. So it really is up to security providers to actually develop tooling that can accurately define the software bill of materials.
And how do you rate the seriousness of this? I mean, to what degree should this be on people's radar? How seriously should they take the possibility of vulnerability here?
Well, we'll start with the basic one, which is, do I understand the software bill of materials for the packages I'm actually using? And if the answer is no, and in most cases it is going to be no, what can be done about it? Because we already are looking for, software bill of materials to detect certain issues, right? We're trying to find license violations. We're trying to find vulnerabilities in commonly used components. Extending that process to make us a little bit more secure is actually required.
So what are your recommendations then for folks who want to do a better job here? How do they get started? What's the best way to approach this?
Well, I would look at additional security tools. If you are not using any software composition analysis tools today, this would be a good time to start, because we've seen that gaps in protection are actually being exploited by the attackers. So we've seen people misusing the known vulnerabilities. We've seen people misusing the lack of vulnerability mitigation protections enabled. And adding additional tooling, both commercial and open source, is required to start bridging that gap and reducing the actual attack surface, so the packages that we provide to other people and other developers are depending on are a little bit more secure.
Our thanks to Tomislav Peričin from Reversing Labs for joining us. The research is titled Third-Party Code Comes with Some Baggage. We'll have a link in the show notes. Thanks to Juniper Networks for sponsoring our show. You can learn more at juniper.net/security or connect with them on Twitter or Facebook. Thanks to Tanium for their sponsorship. Learn more about Tanium as a service and sign up for a 14-day free trial at tanium.com/cyberwire. The CyberWire Research Saturday is proudly produced in Maryland out of the startup studios of Data Tribe, where they're co-building the next generation of cybersecurity teams and technologies. Our amazing CyberWire team is Trey Hester, Elliot Peltzman, Puru Prakash, Justin Sabi, Tim Nodar, Joe Kerrigan, Carol Terrio, Ben Yellen, Nick Valecki, Gina Johnson, Bennett Moe, Chris Russell, John Petrick, Jennifer Iben, Rick Howard, Peter Kilpie, and I'm Dave Bittner. Thanks for listening. We'll see you back here next week.